All right, so today we're doing section 4.9, which is solving quadratics using the quadratic formula. Now, up to now, we've been solving quadratics by using factoring. Okay, so maybe we factored by using the greatest common factor, or the X method, or by grouping, which I don't think we've done it by grouping to solve, but we factored by grouping. Or maybe by using a difference of two squares, we factored and solved that way. But sometimes there's some problems that are not factorable. So when you try to do the X method on it, it doesn't work. Okay, and there's a lot of methods that you can go through in order to solve those types of problems, the ones that you can't factor. One of them is the quadratic formula. There's another one that you can use different ways to do it, maybe completion of squares and things like that. But we're going to work on one of these methods, which is the quadratic formula. So quadratic formula basically states that if you're given a quadratic function in standard form, so given ax squared plus bx plus c, and it's equal to 0, you don't have to factor. They say we can use the following formula to solve the equation. And it says x equals, in other words, your answers are equal to x in our case, right? If they're using like the letters A or M or S, whatever, you can write that for x later on. But you'll see when I do that later. But it says x equals to negative of whatever b is, so negative b, plus or minus the square root of b squared minus 4ac over 2a. So you're multiplying 4 times a times c, excuse me, 4 times a times c together inside that square root. Now remember, there is that little rule that says that square roots cannot have negative numbers inside. So if you do have a negative number inside of a square root, just a little hint for you guys, just to make your life a little easier. So let's assume that you're doing work and inside of the square root you get like a negative 10. Okay? Then automatically just write I radical 10. Notice how the negative disappeared? Okay? Because we're writing the square root of negative 1, that's the negative of a 10, that's the negative 1. We're taking out the negative from the square root and it becomes an I. Okay? So if you had like the square root of negative 4, then your answer is just 2i. Because the square root of 4 is 2, and then the square root of a negative 1 is going to be your I. So anytime you see a negative inside of a square root, so here's another example, like the square root of negative 7 is just going to be I radical 7. Okay, because there is no square root to 7. Or if you had, say, something like the square root of negative 16, well, 16 does have a square root. It's 4, right? So you're going to write 4i. Okay? So just a little hint to kind of help you when you're going through this process, so you don't have to try to rack your brain about, like, what do I do with the negative, right? If you can simplify the square root of the number, then do so. Like on the right side, I have the square root of negative 4, the square root of negative 16. I was able to simplify a 4 and a 16 by finding their square roots. But if you can't, then just take the I out. Okay? Just take out the I, and you should be good. Now, these calculators that I let you guys borrow, these right here, they can simplify square roots. So if you were to put like the square root of 24 in your calculator, it should give you 2 radical 6. Like it can do that for you really quickly. So if this simplifies it, just write the answer with an I in there if there's a negative on the inside. So we're going to do an example with that in a bit. Okay, so this is the formula we're using. If you ever forget it, it's back there. Okay, but try to memorize this one because this is one of the more common algebra functions. So here we go. So we're going to solve 4k squared minus k minus 10 equal to 0. Okay, so we have our ABCs. That's the most important part. Okay, so we just got to write down our ABCs. So let me do that really quick. A is 4, B is negative 1, C is negative 10. Okay, now what you're supposed to do is you're supposed to try to factor this. Okay, And sometimes they're factorable, sometimes they're not, okay? But when they're not factorable using the x method, we're going to go to the quadratic formula, okay? So here's the formula that I'm going to be using. Now remember, the quadratic formula says that it's supposed to be x equals to negative b plus or minus blah, 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 blah. Okay, x equals, well, I'm using k here, so I'm going to write k equals negative b plus or minus the square root of b squared minus 4ac. Remember, guys, I'm the type of person that likes to write out my formulas before I use them. This is how I memorize them, okay? I repeatedly write them over and over again when I do my work. So instead of x equals 2, I put k equals 2, because that's the variable in question, right? 4k squared minus k minus 10. So I'm going to use k. Now, my b value is a negative 1. So when I plug it in, make sure that you put your number in a parenthesis, right? Because you're plugging in a negative number. If you're plugging in a positive number, you don't have to put a parenthesis if you don't want to when it's by itself, but I always do. It's just a good practice. So, square root of b squared, that's negative 1 squared, minus 4 times a, which is 4, times c, that's 10. Okay? So 4 times a times c, oh, I'm sorry, it's a negative 10. I just realized it was a negative 10. I didn't put it down properly. So c is a negative 10. Divided by 2 times a, so let me put that right here. 2 times a is 4. So basically I'm done. All I have to do is simplify this. Okay? So k is equal to negative of a negative 1, that's 1, plus or minus the square root of negative 1 squared is 1, and then negative 4 times 4 is negative 16 times a negative 10, that's a positive 160. Over 2 times 4, that's 8. Again, that's where the calculator kind of helps you, right? In case you're like, I don't know, I can't do that in my head, well, just type in negative 4 times negative 10, and this will give you your positive 160. So, continuing on, I have k equals to, by the way, I'm just cleaning up here, okay? So, 161 on top over 8. Okay? Now, I'm going to get my calculator, and on this calculator, I'm going to put the square root of 161, and then I'm going to hit enter. If anything can be simplified, it'll do it for me. So let's see. It came out to 161 again. So it put the same thing, square root of 161. That means you cannot break down the square root of 161. So this is my answer. I'm done. Okay? But I will tell you, sometimes on some state tests, they want to write the answer like this. I'm not a big fan of it, but I get it. I know why. But they do this. So I want you guys just to see it. They split it. They say, oh, plus or minus? Well, let's write both. We'll do the minus one. We'll do the plus one. Right? So 1 minus the square root of 161 over 8. 1 plus the square root of 161 over 8. And that's it. So sometimes they like to write both. And to be honest with you, on your final exam, sometimes both do come out. Sometimes it'll say plus or minus. Sometimes they'll break them apart. So both of these are correct answers, okay? Make sure you're used to both of them. You understand how to get both of them. All we're doing, again, is we're just splitting this part up. It says plus or minus, so I'm going to write the positive one. I'm going to write the negative one. Okay, that's all I'm doing. So I'm not doing anything kind of weird. I'm just splitting them up. Okay, so we'll do both answers when we're doing this, just to make sure you guys get some practice on both ways. But I mean, would you say that this was crazy difficult to do? I mean, you're just plugging in numbers and letting your calculator do some work, right? So it's not meant to be hard. It's just, it could be a little complicated because you have a lot of numbers. Okay, so just take your time with it. So here's another one. So again, we're doing 3 of these, okay? The last one has, I know, imaginary answers in it. I think the first 2 do not, okay? So this one says solve 2n squared plus 5n minus 12 equal to 0. So again, you can try doing the x method first, okay? So if you were to try it, don't do what I'm about to do right now, but if you were to try it, you would get a negative 24 and a 5 on the bottom. Okay? So and don't do this, by the way. I'm just showing you something real quick. So 2 times negative 12, that's negative 24. The 5 goes on the bottom. Can you think of 2 numbers that multiply to negative 24 that add up to 5? I mean, I would need an 8 and a minus 3. Would that work? Yeah, it does. So do I have to solve this problem using the quadratic formula if I can factor it? No, you don't. You can factor it and solve. Okay? But I don't know if it's going to be factorable unless I try it. So I tried this one. And I can see it will work. Okay? Now, how do I know that it would have worked if I just do the quadratic formula? So right now I'll show you. Okay? Notice how the answers to this, those are your factors. Do you think you would have been able to guess those 2 factors? 1 minus square root of 161 over 8 and 1 plus, right? No, probably not. So this one would have been unfactorable because of the way my answers look. Look what happens when we do this one. Okay? So A is 2. Well, let me change it to green. That way we don't think of that as work that we have to do. A is 2. B is 5. And C is negative 12. Drop something right there. So I'm going to write my formula again. So n is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, this is just the common thing that I do. Notice it doesn't say x in the front, right? It doesn't say x equals. It says n equals. Right? The x in the front changes depending on what letter we're doing. If it was x's, then fine, I'll put an x in. All right, so let's plug it in. N equals negative of a b, which is 5. So notice, even though 5 is not negative, I still put in a parenthesis. Anytime I plug stuff in, I put parentheses around it. Plus or minus the square root of b squared, so that's 5 squared, minus 4 times a, which is 2, times c, which is negative 12, over 2 times a, which is 2. So that becomes negative 5 plus or minus the square root of 5 squared is 25. And then negative 4 times 2 is negative 8. And negative 8 times a negative 12 is a positive 96 over 4. All right, 25 plus 96. That's 121. Let me make sure I calculate that really quick correctly, just to make sure. So yeah, so it'd be 96. So 96 plus 25, it's going to be 121. So n is equal to negative 5 plus or minus the square root of 121 over 4. Do we know the square root to 121? It does exist. That's 11. All right. So the square root of 121 is 11. Okay. So notice I don't have any more square roots. Right? I don't have any more square roots. That means that it was probably factorable. And I just showed you before, I was able to pick 2 numbers, negative 8 and 3, that would have worked. I would have to divide them by 2 eventually. But it would have worked if I would have done it the old-fashioned way. The thing is, the quadratic formula says, why are you worried if it works or if it doesn't? I'll solve it for you. Just feed me the information. I'll solve it. Who cares if you can factor it? I'll solve it for you. Okay? So here we go. Let's get our 2 answers. One of the answers is going to be negative 5 plus 11 over 4. The other one is going to be negative 5 minus 11 over 4. Those are my two answers. So let's figure them out. Let's start with the first one. I'm going to kind of move my work over here. So I'm going to get my calculator, okay? I'm going to put negative 5 plus 11 and then divide that by 4. And I get 3 halves. Okay? And then the other one, I'm going to do negative 5 minus 11. So negative 5 minus 11, divide that by 4. So I get n equals to negative 4. Here are my two answers. Negative 4, comma, 3 halves. Okay, so I'm going to kind of color code it really quick. That way you guys know. This answer is this one. Okay, and then this answer gave me this one. All right, when I calculated them, when I actually simplified them. So again, how do I know it's factorable? I don't have any leftover square roots, right? Not like the other problem where I had the square root of 161 and it was stuck there, right? This one has normal looking numbers. So that's how I know I could have probably used the X method. But does it matter that I didn't? No, I get the same answer. It doesn't matter. Okay? So don't be like, oh man, should I do it or not? You can use it all the time. Unless the instruction says use the X method to solve, then you're going to have to show me you know how to do the X method. But if not, you got to use the formula. Or you can use the formula. So we got one more to do, and this one's going to involve some I values. Okay? So I wanted to show you one example where the answers come out with square roots in them. One example where the square roots go away, okay? And then I want to show you one example where we have imaginary solutions. So that's why I said 3 examples, that's all. So this one, we're going to solve 3b squared minus 2b plus 2. Now sometimes this can be a little confusing for some people because the formula has an A, a B, and a C in it, and this one has B's in the equation. Don't get confused with the B values. It's just a variable. Okay? So if you don't like it, you can change them to X's if you want. But here we go. A is 3, B is negative 2, and C is 2, according to the ABC coefficients. Okay? So here we go. So B is equal to, now again, I know this is going to look kind of weird because my formula happens to have B's in it. But just kind of get past the first step and you'll be fine. Remember, this B that I'm putting in quotes, that's for the variables. Okay? Not for the numbers. All right. So B is equal to negative of a negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times 2. All over 2 times A, so 2 times 3. Okay, again, the formula is easy to use. The computations, that's when you can mess up, so be careful, okay? Plug in the numbers correctly, take your time, do the multiplications. You know, don't rush through this stuff. It's too easy to get it wrong. I know it sounds weird to say that, but this work, your calculator will do most of the work for you. Don't mess it up, okay? So, B is equal to positive 2 plus or minus the square root of, now negative 2 squared, that's 4. And then negative 4 times 3, that's negative 12 times 2, that's negative 24 over 6. Okay, so now that we have that, let's go ahead and simplify a little bit. So B is equal to 2 plus or minus the square root of negative 20 over 6. What did I tell you to do if there's a negative inside the square root? Take the I out, right? So b is equal to 2 plus or minus I square root of 20 over 6. Now I'm going to get on my calculator and I'm going to type in square root of 20 and hit equals, and it tells me it's 2 square root of 5. So the square root of 20 is 2 square root of 5. So 2i square root 5 over 6, because the square root of 20 becomes 2 square root of 5. So I put the 2 in the front and then square root of 5. Now I'm almost done. You notice how on the top there's a 2 plus or minus a 2 and then I square root of 5, all divided by 6. So 2, a 2, and a 6. What number do they have in common? A 2, 2, and a 6. These right here. A 2, right? This, and this can all be divided by 2. So let's do that. Because you can reduce. So that's going to be 1 plus or minus 1i square root of 5. I'm not going to put the 1 next to the I because it's going to look kind of weird. Over 3. And this is your answer. And again, if they want to split it up, it's going to look like this. 1 minus I square root of 5 over 3. 1 plus I square root of 5 over 3. Now there's one little hint I'm going to kind of tell you guys about, and then we're going to be done. Because you can find out whether or not you're going to have real solutions or not before you even do any of the problem. And that's called, there's a little piece in this thing called the determinant. Okay? So, I'm going to write it down. The determinant. Not the determinant, the, what's the word I'm thinking of? Sorry, so it's not the determinant, it's the discriminant. Okay? And it's part of the formula that we've been using. B squared minus 4ac. Right? That's the part inside of the square root. Okay? So I'm going to write it 3 times. Okay? Because this can tell you how many answers you're going to have. Okay? If the discriminant equals to 0, so if you get b squared minus 4ac and you calculate it and it equals to 0, you'll only get one solution. Okay? If it's greater than 0, so let's say inside the square root it comes out to 18, so greater than 0, you get 2 solutions. And if it's less than 0, you get no real solutions. So if it's less than 0, you can get 2 imaginary solutions. Now, why do I show this to you guys at the end? It's because every once in a while, they're going to ask you guys, you don't have to solve, but how many answers would you get for this problem, right? So they give you something like 5x squared minus 3x plus 10. They're like, how many answers would you find? So all you use is a discriminant, the b squared minus 4ac. You put your numbers in there, and then whatever the answers come out to, you either have one solution, no solutions, no real, so 2 imaginaries, or 2 solutions. So if it's greater than 0, you get 2 solutions, less than 0, 2 imaginary solutions, and 1 solution if it equals to 0. So if they ever ask you that on a test or in the homework, like how many solutions does this have, use the discriminant, and that'll tell you it's going to have either 2 imaginary, 2 normal, or only 1. Okay? So that's what the discriminant is for.